Hello everybody. In this video, I'm going to talk about a special type of thermostatic expansion valve commonly known as MOP, what it is, how it works, and where it should be used. Thermostatic expansion valves can be grouped into three main categories based on the type of charge in their thermal bulbs: liquid charged, vapor charged, and adsorption charged. In this video, we'll focus on the vapor charged type, often referred to in the trade as the MOP type. First, let's take a look at what MOP stands for. MOP can stand for either maximum operating pressure or motor overload protection. Now, let's take a look at how this type of valve operates. Here, I'll briefly explain how the liquid charge type works, and then we'll move on to the MOP type. In a liquid charged valve, there is enough liquid inside the thermal bulb that it never fully evaporates over the normal operating temperature range. So, when the temperature at the evaporator outlet rises, the bulb temperature increases as well. As a result, some of the liquid inside the bulb evaporates, which increases the pressure inside the bulb. This pressure is transmitted to the top of the diaphragm, causing the valve to open further. Keep in mind, the liquid inside the bulb never completely evaporates. Now, let's take a look at how the MOP type works. Inside the bulb of an MOP type valve, there is enough liquid for it to operate just like a liquid charged valve, up to a certain temperature. This means that as the evaporator outlet temperature rises, some of the liquid in the bulb evaporates, increasing the bulb pressure and causing the valve to open further. However, once the bulb temperature reaches a specific point, all the liquid inside evaporates. From this point onward, even if the temperature continues to rise, the pressure in the bulb no longer increases, because there's no more liquid left to evaporate. As a result, the valve stops opening further beyond that temperature. So, in what kind of applications would we want the valve to stop opening beyond a certain point? MOP expansion valves are used to temporarily protect the compressor from overload when the temperature of the fluid entering the evaporator is higher than the design value, indicating a high initial load on the evaporator. A typical example is in water chillers, where the entering water temperature may be elevated at startup. This also applies to refrigeration systems where the initial load is temporarily high. Additionally, MOP expansion valves should be used in systems where the compressor cannot operate above a certain evaporating pressure or temperature. This is the case with some Bitzer compressors, such as those designated as Motor 2 or 3, and with two-stage compressors. In such cases, using an MOP valve ensures the compressor operates within its specified operating envelope. Liquid-charged and MOP-type valves differ in the amount of liquid inside the bulb, but they cannot be distinguished by appearance alone. That's why manufacturers mark the word MOP on the head of the valve. As you can see, there are usually numbers following the word MOP, but what do they mean? If a temperature is indicated, the unit, degree Celsius or degree Fahrenheit, will be shown. If there is only a number without a unit, it refers to pressure in psi. For example, take a valve labeled MOP 20 or minus 20 degrees Celsius. This means the MOP limit is 20 psi or minus 20 degrees Celsius. Above that, you might see R22 and R407C, which means this valve is designed for use with R22 or R407C refrigerants. If you check the pressure temperature chart for R22, you'll see that 20 psi corresponds to a saturated temperature of minus 20 degrees Celsius. So, what does this pressure or temperature represent? It means that when this valve is installed in a system, the evaporating temperature inside the evaporator will not exceed minus 20 degrees Celsius, regardless of the outlet temperature. In other words, this is the maximum evaporating pressure or temperature allowed by the valve, and the system will be limited to that. Now, let's take a look at this example. The expansion valve used here is an MOP type, with an MOP temperature of minus 5 degrees Celsius. This means that, regardless of the load or the superheat, the valve will only open enough to maintain a maximum evaporating temperature of minus 5 degrees Celsius, and no higher. When the load decreases, the temperature of the fluid being cooled drops, and the evaporating temperature falls below minus 5 degrees Celsius, the gas inside the bulb condenses back into liquid. From that point onward, the valve operates just like a liquid charged valve. Now, let's have a look at a real-life example. The chart shown represents the operating cycle of an ice cream mix pasteurizer, recorded using a Testo digital pressure gauge. This machine heats the ice cream mix to 85 degrees Celsius in a tank, after which the refrigeration system starts to cool it down. The expansion valve used in this system is an MOP type, with an MOP temperature of 0 degrees Celsius. I've drawn a dashed line at 0 degrees Celsius, indicating the MOP limit. At this point in the process, the tank temperature reaches 85 degrees Celsius and the refrigeration system activates. Here, there is a very high initial load on the evaporator, but the MOP valve keeps the evaporating temperature close to 0 degrees Celsius. Initially, the evaporator outlet superheat is quite high, but it gradually decreases as cooling progresses. As you can see, the MOP valve maintains the evaporating temperature near 0 degrees Celsius, preventing compressor overload and potential failure while the fluid temperature is still high. If a liquid charge valve had been used instead, the evaporating temperature and pressure could have risen excessively, potentially leading to compressor shutdown due to overload. Thanks to the MOP valve, the machine was able to cool the mix down in about 38 minutes, without triggering compressor overload. This is a real-life example of how MOP valves are not just useful, but essential in certain applications. There is an important installation tip that must be observed. The head of the valve, where the diaphragm is located, must be warmer than the thermal bulb. This is crucial because when the valve is operating in MOP mode, meaning all the liquid inside the bulb has evaporated. If the valve head becomes colder than the bulb, the gas inside the bulb can migrate and condense inside the valve head, causing the valve to close unintentionally. In practice, this issue can be prevented by installing a special wire-type heater on top of the valve to maintain the necessary temperature difference. I hope you found this video helpful. Thank you for watching.